Morning, guys. Shirt Tails and I are here again with another installment of solving for complex shapes and centroids. Today we're going to solve for this shape, and we're going to do this shape a little differently. We're going to use the same 4 steps to solve for centroid complex shapes, but we're going to break this one up a little bit differently. When I look at this shape, normally I would probably break this shape into this triangle and this rectangle here on the bottom and do it as an additive method, just like we did the last time. However, in order to teach you another method, we're going to do this one slightly different. And so I want to teach you this, what I call the subtractive method today. And so let's take a look at how to break this shape up. So what I've chosen to do here is break this up into a large rectangle. So shape 1 is actually this entire rectangle here, and then shape 2 is formed by this corner that I squared out in this angle. Shape 2 is this little triangle up here. So as you can see, if we started with this large rectangle, we're subtracting shape 2 away from shape 1. So again, to review real quick, our steps for solving for a complex centroid shape is number 1, to break the complex shape into simple shapes. Number 2, redraw our shapes relative to a 0, 0. Step 3, solve for x bar, y bar, and area of each of our simple shapes. And then step 4 finally is to calculate the centroid of the complex shape, or calculate x and y bar of the complex shape. Okay, so as you can see here, I've redrawn shape 1 and shape 2 relative to their 0, 0. So now the next step would be to calculate x bar, y bar, and the area of shape 1 and 2. Shape 1 should be pretty simple for you, should be very similar to what we've done in the first video. If you haven't seen the first video, I'll link it here. You can go back and watch the first video. Go ahead and pause the video, take a second, see if you can solve for x bar, y bar, and area of shape 1, and we'll come back and go over the right answer here. X bar equals 3, y bar is 10 divided by 2, y bar equals 5. Okay, so now we go look at shape 2. Shape 2 is not located at the 0, 0. So the first thing we need to do is get to the right angle of the triangle. Remember, your formula for triangles acts from the right angle. So before you do your formula, you always must get to the right angle. So if we look at the location of our right angle here, our right angle is located at 6, 10. Okay, so that is the location of that, and then we will use our x bar formula to move from that location. So x bar of shape 2, we take 6, our location of where we're at, and we're going to subtract base divided by 3, because when we are right here on our formula, our centroid is going to be base divided by 3, but back in a negative direction from 6. It's going to be closer to the 0, 0 than the 6 inches. So we take 6 minus base divided by 3, because our centroid and our formula is taking us in a negative direction. So as you can see, x bar of shape 2 is 6 minus 6 divided by 3, which is 6 minus 2. X bar is 4. Go ahead and pause the video, take a second here, solve for a y bar, see if you can get it right, and we'll come back and we'll check your answer. So as you can see, y bar of shape 2 equals 10 minus height divided by 3. 10 minus 4 divided by 3, you get a y bar of 8.66 repeating. Now you need to calculate the area of shape 2. Go ahead and take a second to do that. area of shape 2, half base times height, triangle, 12 square inches. Now that we've got all our information for shape 1 and shape 2, it is time to take a look at our complex shape centroid formula. So here we have the formulas for x bar, y bar of complex shapes. X bar of the complex shape equals the sum of x bar I times area I divided by the sum of area I. Again, that's just x bar of shape 1 times area of shape 1 plus all of the shape. Do that for all the shapes, add them together, and then the sum of area I. Now, sum of is a little bit deceiving when we start using the subtractive method. Remember, shape 2 is subtractive. We are subtracting shape 2 from shape 1. So if we look at shape 1 here and we draw in the triangle, we are taking shape 2 away from shape 1. So since we're taking it away, even though the formula is sum of, we're actually going to subtract x2 times area 2, and we're going to subtract area 2 on the bottom. So that looks kind of like this. So we'll take x bar of shape 1. X bar of shape 1 is 3 times the area of shape 1, which is 60, and then on the bottom we have the area of 60 for shape 1. But here, shape 2, remember, is subtractive. So we're going to subtract the x bar of 4 times the area of 12 for shape 2, and then subtract the area of 12 for shape 2. Take a second here, do this on your calculator. And once you do that on your calculator, you should end up with 132 divided by 48, or an x bar of 2.79. All right, we're going to go ahead and do the same exact thing with our y bar. Go ahead and take a second, pause the video, see if you can solve for y bar, and we're going to come back and take a look at the right answer. Okay, so as you can see here, y bar equals 5 times 60, x bar or y bar of shape 1 times area of shape 1 minus 8.66 times 12, which is the y bar of shape 2 times the area of shape 2, over 60 minus 12. Remember, we're subtracting the 8.6 times 12 and the 12 on bottom. Because shape 2 is subtractive, we're removing that material from the object. Okay? You should end up with 196 divided by 48 for a y bar of 4.08. Now, if we look at that and think about that, 2.79 shifted this way a little bit from center because the center is 3, and 4.08 shifted down this way. That makes sense. There's more material lower on this object and there's more material to the left on this object. So in order to balance it, we would have to put our finger downward and to the left from the dead center of the object. So that makes sense. Hopefully this makes sense. Apply this. You're going to have to use the additive and subtractive method on your worksheet for today. You've got 4 shapes to do today. None of them require more than 2 shapes for today's homework. And good luck with it. And if you've got any questions, don't hesitate to contact me via all the means that we have for contacting. Have a good afternoon.